Okay, we're going to talk about the time of flight mass spectrometer. Now, what's it for? Well, you can find out the relative atomic mass of an isotope. You can find that. Also, it will give you the percentage of each type of isotope. So, for example, you've got, let's talk about chlorine, because everyone's pretty familiar with that. Chlorine, we know that you've got 35 Cl, which is about 75% of chlorine is that isotope, and you've also got 37 Cl, and 25% of it is that. Well, the mass spectrometer is the way in which people have determined that this is what the relative isotopic abundances of chlorine. It can also be used, shown in red here. You can also use it to find out the MR of a molecule. Obviously, the molecular weight of it's going to be a molecule, so you can put quite big molecules in there and find out the mass of them, which can be quite useful in if you made a new compound and finding out what that compound is. Okay, so here is the mass spectrometer. It's a big tube. I think it's usually about 2 meters long, and here is a vacuum. Okay, now what is introduced at this end is you put your sample of elements in there. We'll talk about elements rather than compounds at the moment. So you put your sample in there, vaporized sample. Now in this chamber, it is ionized. Okay, so for example, if it's chlorine, what will happen is it will be bombarded by an electron. So it's chlorine gas, hit it with electrons, and you'll turn it into chlorine, a positive ion, and obviously an electron will come there. Okay, and that's done by electron bombardment, generally speaking. If you're using molecules rather than atoms, it's usually done by a different method called electrospray ionization, which we can talk about later. But don't worry about that for the time being. So what we're going to have here is you're going to have a load of ions being made. Now in this second bit here, you've got a voltage. Okay, so you've got a voltage across here. So this is going to be negatively charged, and this is going to be positively charged. And it's several hundred volts. Okay, so it's an electric field. So what's going to happen to positively charged ions in here? Well, they're going to be attracted towards this negatively charged plate. They're going to accelerate. Okay, now let's talk about that acceleration. Now a little bit physicsy here, right? We know probably that the energy transferred to a charged particle in an electric field is given by the charge multiplied by the potential difference, the voltage. So it's quite important here is that each ion, because they're all 1+, all got the same charge, same voltage, each ion will be accelerated. Each ion, when they're accelerated, is given the same kinetic energy. They get the same kinetic energy there because they're both accelerated through the same voltage. So the ions are going to be accelerated there. So imagine in here now we have got, right, I'm going to do a 30, so, and then they can escape through this hole here, and they're going pretty fast. So we've got 35 Cl here, and we've got 37 Cl. Now, if you remember your equation for kinetic energy, you need to know this, is a half mv squared, where m is the mass and v is the velocity. Now 35 and 37 have both been given the same kinetic energy, but 37 is heavier than 35, so that means the velocity of 37 is going to be slightly slower. So let's just write that down. So we'll say both 35, don't forget, is positively charged, and 37 get the same kinetic energy, but because M is greater for 37 Cl than 35 Cl, we can say positive. We can say that 37 has a lower velocity. Well, they're going to move across this tube, aren't they? Okay, and you can see that what's going to happen is the 35 is going to start getting ahead of the 37 because it's going faster. So the 37's not got quite as far. So that means this is the detector here. Who's going to get to the end first of all? It's going to be the 35s, aren't they? Okay. Now we'll talk about how the detector works in a minute. It's not just that, but let's just think about what we get here. So if we got a, this is detected, and this is time. You're going to get two little peaks here, aren't you? You're going to get two little blips. You're going to get one there. That's all the 35s arriving, yeah? And a tiny bit later, you're going to get this one here. That's all the 37s arriving. They're a little bit later. Okay, so you're going to get two peaks. Now, this time on this axis, this can be calibrated into atomic mass units. And usually this detected is, so you have abundance. And that's probably in percentage, 100%. So you can see, the way I've drawn it there isn't quite right, but that should be about 25%, so that should be about 75%. That peak is high, and this one's only a third of the height, that's 25%. So you can tell you've got 75%, 35, and 25%, 37 chlorine. So that's how it works. We need to know how the detector works. Okay, now the detector is here, right? And what happens is you get a 30, let's you get a positive ion, let's say it's 35. Positive ion, that hits the detector. What happens is an electron will come out of the detector. Now here's a wire, okay? That's a wire. And you're going to have an electron is going to come out of that wire, and because that's positively charged. Right, so in this wire, you're going to have a current flowing, yeah? Because you've got electrons moving down there. And the size of the current is going to be proportional to how many ions are detected. So that's what here gives you different size peaks. In this bit here, you've got a different amount of current flowing. So the things most of the questions they ask on this are all to do with calculations on calculating the time of flight, but the more descriptive questions are all to do, they want you to know the following things. They want you to know is, how is the sample ionized? Well, that's by electron bombardment usually. Why has it got to be ionized? Well, if it wasn't ionized, it wouldn't be positively charged, and it wouldn't be accelerated, would it, up here in this bit? You wouldn't get any acceleration here. So that's why it needs to be positively charged, okay? Why ionized? So it can be accelerated. Number 3, right, how is it accelerated? by having that negatively, that plate at a negative voltage, in other words, having by an electric field. And finally, how are the ions detected? And that's what we said here. You have the ion, an electron flows to neutralize the positive charge of the ion, and the size, the number of electrons flowing is electric current. The size of the current is proportional to the number there. So that is how the time of flight spectrometer works. So they don't ask that many questions on it, but we now need to, the next video is do some calculations.